Hi everyone, I am Abdul City Aliyah Jan Al Abdul, and for today's video we're gonna tackle activity 6, which is titration. For the objectives, first, to know and understand titration. Second, to know the importance of titration in the laboratory. Lastly, to know the apparatus needed in titration. So what is titration? It is a process of chemical analysis in which the quantity of some constituent of a sample is determined by adding to the measured sample an exactly known quantity of another substance with which the desired constituent reacts in a definite known proportion. Apparatus needed in titration. So what is burette? Burette is an essential laboratory instrument commonly used in titration process for quantitative analysis in many industrial chemical tests where solutions of known concentration are used to find the concentration of unknown solution. How to perform titration. Part 1 of 3. Part 1. Setting up your equipment. First, gather all the necessary equipment before starting. Second, rinse and purge your burette. To get an accurate reading from your titration, your burette must be completely clean. Third, clean and rinse all glassware. Rinse out all glassware you will be using, including any beakers or flasks, with deionized water. Fourth, fill the burette with an excess amount of titrant. The titrant should be in a liquid form. Fifth, clamp the burette carefully to a burette stand. The burette should be secure enough so that it does not move or slide. Lastly, tap the burette to remove any air bubbles to the burette stand. Part 2 of 3. Conducting your titration. Number 1. Measure out a precise amount of analyte in a clean beaker or flask. You need to know exactly how much of your analyte you are using so that you can calculate your end concentration. Second, drop a small amount of color indicator into the beaker. Many titrations require the addition of a color indicator prior to adding the titrant. Third, add your second chemical if necessary. While not all titration experiments require a second chemical, some. Fourth, agitate the beaker using a magnetic stir plate. If you have a magnetic stir plate available, place your beaker on it and drop the agitator into the beaker. Fifth, place the beaker under the burette. The burette should be centered over the beaker. The tip should not be touching any of the beaker walls. Sixth, slowly open the stopcock so that the titrant drips out of the burette. The titrant should come out of the burette drop by drop. Lastly, record your final volume from your burette. Once you've reached the endpoint of your titration, close the stopcock and record the final volume of your titrant in the burette. Part 3 of 3. Finishing your analysis. Number 1. Dispose of the chemical used in a labeled waste container. Once you have completed your titration, empty out your beaker, your burette, and other glassware you use into appropriate containers. Second, clean your glassware by rinsing them with water. If possible, use deionized water to rinse out your glassware. Lastly, calculate the concentration of the titrant. Every type of titration will require a different calculation to determine the concentration of titrant in your analyte. Why is titration important? Titration is an analytical procedure in which a scientist uses volumetric addition of a titrant solution with a known concentration to determine the unknown concentration or quantity of an analyte. The analyte and titrant react in a known stoichiometric relationship, with the reaction consuming all of the analyte at some time during the addition of titrant. The unknown concentration can thus be determined using the volume of titrant added and the molar stoichiometry. Why do we titrate in the laboratory? It is used to precisely measure an unknown molar concentration in a known solution. The fundamental procedure entails mixing a standard solution of one reagent with a known amount of unknown reagent solution. Generalization. Titration is important not just in chemistry but also in our daily life, making it an essential analytical tool and quality control test. To acquire an accurate result in titration, we must be clean, attentive, and mindful of the apparatus we will use and the procedures we will follow.